Hello, this is Paul from Foresight Tech. Here, let's prove the Theorem 1.9.1, which is the composition of matrix transformation. We have this theorem. Suppose we have the first transformation, matrix transformation, and the second, then TB circle TA. This we call the composition of these two transformations. And the theorem said the composition is the matrix transformation, and the corresponding the standard matrix is just B times A. Why? Okay. So I can show this. Let's prove. So the first, let me draw a graph to describe the two transformation. Like if okay, so this is Rn. Let me simply say this is n space, and this is Rk, and the third one is Rm, and then we have the first transformation. It's from here to here. Let's say the first transformation is TA, and then the second, of course, mapping this to the third. Let's say it's here. That's TB. The composition means give the beginning directly jump to the end. You can say like this: we directly jump to the end. Okay, so the final, which is TB, right? So TB is the out and the TA is the inner. So that TB circle TA. This is another transformation from the beginning directly to the end. What this transformation equals. Okay, the theorem said this is also a matrix transformation. The standard matrix is here. Pay attention to the order. Is not A times B, but B times A. Okay, the second go to the first go to the second. So let's say by the definition, all we need, I make the beginning is X. Is that okay? And then I find the middle. What is the middle? The middle should be TA, which is So let's just see what is the end. Is that okay? So let's find out what is there. If we can find the purpose, if we can find the end, which is B times A times X. Therefore, the mapping is just a matrix transformation, right? Okay. So how to do this? We can find, say, okay, given this X is any, so X vector belongs to the beginning, which is our n space, and then we can find out what is, and let's find out what is the image of the B circle TA at X equals. Okay, that's our purpose. So let's go. Let's move on. By definition, so TB circle TA at X. TB circle TA at X. So how did we get this? We have to use TB first, right? So which is TB at this middle. This middle I put here should be TA at X. Is that okay? And then there's TA at X. TB mapping this point to the final. Okay, so that's the definition, right? This definition of the transformation of the composition. And then one more step. What is TA? What is this? Okay. TA, this we see this point. So what is TA at this? Definitely we know this should be A times X, right? Because TA is a matrix transformation, A is the corresponding standard matrix. Okay, therefore we have A times X. And this is also a definition. Also a definition for the matrix transformation. And then one more step. Because TB is also a matrix transformation. So therefore I get this should be B times A times X. And it is also a definition. So all the definition. And then by matrix now, because the matrix multiplication, by associated, this is BA times X. It's associated. Makes sense, right? Okay, what is this? This is a matrix transformation. So we finally, this is by the definition, this is a matrix transformation. The standard matrix, of course, is B times A. So it's B times A at X. Yeah, definitely. See, we get it. This is a matrix transformation because we find the standard matrix. That's the proof. Thank you.